the challenge is that even if we say, okay, we have all this, we have more demand, let's just build more plants. And the reality is that the lead time for a combustion turbine can be 5-10 years. Well, what do you do in the meantime?
Yeah.
And that's the problem.
What do we do in the meantime?
Exactly. That's what we're trying to solve for is getting out as much efficiency out of the existing generating assets as we can.
The world of energy and the technology shaping it. I'm Josh Tate, and this is Between Two Turbines. Powered by NAES. Nancy, welcome to the show.
Hi, Josh.
So tell me what it is you do for NAES.
When I started here, I started as an engineer. So I worked, on our engineering team and did a number of different things. It was like traveling to plants and trying to help them, solve problems that arose. How that kind of got me into this role was really getting to be in the forefront of how NAES makes that transition from being more of an industrial operator to moving into technologies that are really like front and center today, like AI, robotics, all of it. So it was a very exciting opportunity. And again, when I read through the job description, it was really about, well, how do we get the most out of this partnership that we've made with Gecko? And it was really about, needing to, one, have a good understanding of the NAES culture and know who in our NAES plants that we could work with and trying to bridge that relationship. So it's needing to have that fundamental understanding of what NAES does and relationships across NAES in order to get them comfortable with, working with a partner like Gecko, which is very much in a different space than them from a technology perspective. And how do we marry those two? How do we get our plants, our people comfortable with technology and bring it into their facility, which is very new to them.
Totally. I want to go back a little bit. So you started in kind of the engineering side of things, moved your way to management side of things. What got you interested in kind of going into the engineering? What brought you here? You said 17 years ago.
I studied metallurgical engineering back
What
in
is
Canada.
that? Metallurgical engineering. Tell me about that.
Yeah. So metallurgical engineering is really I always described it as kind of marrying mechanical engineering and chemical engineering. Okay. So, I did a lot of like metal failure stuff. I've worked in a metals processing refinery. It's really about, how you more efficiently extract metals from ore, right? Yeah. And how you get it into a usable product.
Right.
So again, before I got into power, I worked in a precious metals refinery, a cobalt refinery. I did some metallurgical coal processing. So again, very industrially heavy industries. And then I made the move. I worked for a nuclear power plant in Canada. And in that role, how I used metallurgy was more around, like, we did a lot of equipment or maybe piping integrity, right? So it's like you have issues with corrosion, you have issues with material failures. Right. And that stuff happens obviously in non-nuclear plants as well. But so that's really what I did for them, and over so I spent 4 or 5 years doing that. And at the time, my husband was he was doing software engineering, which he got recruited by Microsoft. So it was a bit of
brought up here.
Yeah.
And you thought doing the nuclear thing, metallurgy, new word for me. Yeah. I like it. Made a easy transition to what NAES was doing.
Right. Because again, I mean, I guess the interesting part is that, in nuclear, it's very regulated. There's a lot of process and there's a lot of, I would say impediments to getting work done just because it's so heavily regulated.
Red tape,
lots of red tape.
Yeah. There's high level of concern when it comes to nuclear, although obviously the upside is quite high. Yeah.
When I made the transition to NAES, the thing that stuck out the most to me was that there wasn't as much red tape, that I could go and freely walk around a site, that I could interact so easily with the folks that were, running
On
the
the
plant.
ground.
Yep.
Yeah.
Yep. Because, in the nuclear world, you would have to, it's almost like military in a way. You would have to ask permission to enter.
Right.
You would have to.
Lots of gates to get
Yes,
through. And
yes.
security guards.
Exactly. If you had to go out into the facility to look at something, you would need to, like request permission to go to that area, have all the paperwork filled out for why you wanted to go, what you were going to do, what the reason was, because there was just lots of red tape, and there was obviously a lot of reasons for it.
Yeah,
You have that extra element of, are you going to, get any radiation or dosage in that area? So there was certainly some different safety concerns than what we have on the conventional side.
Yeah, I kind of think of it similar to the aviation industry.
Yeah.
It's, people always say it's much safer than driving.
Yep.
Obviously, we've had some issues recently, but at the same time, it still exceeds safety, compared to driving or other means of transportation. And I imagine in energy, the feeling is similar about things like nuclear.
Yeah.
Going from that, bringing your knowledge to NAES, I imagine it probably felt like a little bit of a breath of fresh air, is more freedom to pursue different things. What was kind of the first thing you dove into when you got here?
The first site that I actually went to was our Harquahala site in Arizona, and it was a combined cycle. And I was there actually during one of their major outages, but I was there looking at high energy piping. So high energy piping, became an issue because there was a lot of issues with welds. So when you weld high energy piping, like a P91 to carbon steel, they started to figure out that, actually the processes for how we did that could inevitably lead to failures. So my project initially was going in and observing the contractors that we were bringing in to kind of do that testing, and then help the plant kind of, because it was different language, right? If you're not a metallurgist, some of the, you get a report at the end and you're like, okay, well, what does this mean? What do I need to do with this? So it was helping the plant understand and interpret what those reports were saying and where the risk really lies. And what, when we did, and we certainly did over the years, uncover issues where something had to be corrected. Well, what does that look like? Who's the right vendor? Who's the right partner to take this on? How do we validate that they've done it correctly? All of those processes. So my first real project, with NAES was kind of using some of the skills that I had developed, in metallurgy and in the power industry and on the nuclear side, for just helping. It was something that was relatively new, and we were sort of still learning about what the potential issues with this type of, with this, because again, the material itself had a lot of really good benefits, but if you didn't do everything exactly right, there was just potential for pretty severe consequences should those pipes fail.
Yeah.
So it was, getting the plant to feel comfortable that what they had in place when they would come out of this outage wouldn't be something that would, bite them later on.
I'm curious, in those situations, I think of trust as like its own form of currency. And I wonder for you, what does that trust building process look like with some of these plants to say, you got to stop everything, you got to fix this, you have to do this? How do you go about that?
Yeah. I mean, again, we were never going to be the final decision for them. That it really what I would say I was tasked to do was just to give them all of the available options, and then they would have to go and back and evaluate the risk and the cost with their client and make that decision. But I think the trust building was just being, clear and frank about what the options were and what the potential risks were, and not exaggerating it and not underplaying it. Was, and also just helping them, because oftentimes you're bringing in contractors, it can be difficult to build that trust immediately, especially when, you're like, well, this vendor who's telling me to do this thing. Yeah. They also get the
short-term sale they're thinking about, or are they thinking long-term implications?
Right. Or are they pushing me to do something that, maybe it is a good thing to do, but is it needed? Is it necessary? Yeah. Could we handle this a way that is less costly, that is, less disruptive, right? Because, if you discover something during an outage and your outage goes longer, there's real financial impacts to that. Yeah. So So
course.
I would say, on your question about building trust, is really just being clear and open and letting them know how you got to that conclusion.
Yeah.
What's leading me to say, hey, if this was me, if I was making this decision,
This is what I would
this
do.
is what I would do.
If you were my mom or dad, this
Yeah.
is what I'd tell you.
Yeah.
So I used to work in sales, and sometimes that's what I'd say is, I'm not trying to pull one over on you.
Mm-hmm.
I'm trying to help you.
Yeah. And I think the other thing was that we were independent. I mean, when in our NAES engineering team at that time was very small, but we had nothing to gain from the advice that we were given. What we were communicating was really just, hey, this is my experience. This is what I see as the risk.
Right.
And this is the recommendation that we give. And also, especially at the time, I was certainly a more junior engineer.
Right.
I had folks like Bill Lovejoy and others on my team that I would be like, hey, this is what I'm seeing. Do you concur? We had partners in the industry that we felt like we could go to and say like, hey, because of other relationships that we had built, to say like, hey, this is what I'm seeing. Do you agree with this analysis and all of that? So there was also the behind the scenes vetting to make sure that that the advice that we were giving was sound. But again, we had nothing to really gain from it other than wanting to help them make the best possible decision.
Absolutely. And my experience being here is that is just kind of how we approach everything. Is we're thinking the long game.
Right.
We want to make decisions that actually help our clients, because if we truly help them long term, it helps us.
Yep.
Makes the world go around. So I want to kind of transition from your background and then leading to this partnership that NAES has gone into with Gecko. And I think we should get an elephant, is in the room here. Are you guys going to replace me with a robot?
Yeah.
Is marketing gone? Is we just going AI and robotics on our side, or should I be worried?
You should absolutely not be worried. And honestly, when we initially started the partnership and we started thinking about this, the problem statement that we have in mind around like, why are we looking at this now? Why are we trying to find some other solutions is just the reality of where things stand today. 10, 20 years ago, there was always a mentoring, there was stronger mentoring programs.
Sure.
In sites, in power plant sites.
Pipeline of new employees coming through.
Pipeline of new employees to make sure that they were being trained up to replace those that were exiting.
Yeah.
And as economics of the plant changed, as financials changed, as some of the market conditions changed, that kind of went away to the point where you were trying to operate with the least amount of staff as possible.
Right.
So now, what that has led to is that we have, we limited hiring. We did not have people kind of slated to shadow those that were, in other positions. And now as people are retiring, we're finding that, well, one, there just isn't someone that can replace them. And we're not investing in the time needed to get someone up to the level of someone who's been at the plant for 20 years.
Requires a lot of training and preparation. And I imagine for some of these jobs, you're in a more remote location. I wonder if some of these younger people, if they're thinking, I want to be an influencer or I want to work at a power plant,
right?
And obviously we understand the value of a stable job that contributes to society.
Yep.
But I wonder, market conditions, all those things. It sounds like we're running into a problem.
We just have a larger outflow of knowledge and talent. And those that are coming in to backfill it, one, to your point, right? It's not necessarily considered the job of the day, right? It's not something that kids or younger folks are getting that excited about.
Sure.
They're not necessarily excited like, yes, I want to go work in power.
Sure.
They may be, I want to work in AI. I want to work in robotics. I want to work in finance, that kind of stuff. But they're probably not thinking about in the same way as the generation leaving that, hey, I'm interested in this industry because it's stable, because, I see that it'll be a good, just a solid job that contributes positively to society and that there's a need for. So what's that creating, right? A gap, a knowledge gap, a very big knowledge gap.
Yeah.
One, it's just getting people in the door, particularly INC techs or those that are, coming in on the trade side. Because a lot of the management, had kind of worked through either they did engineering or did something else or were operators that they just moved up through the ranks, and that all takes time. So some of the problem that we're trying to solve is just that, the knowledge gap between the people. I mean, I know, when you hear this title and this partnership, it's easy to focus on robotics, that's the exciting piece.
Yeah.
But where we're actually moving towards is how do we ingest all of that knowledge of the person that's exiting and make that accessible to the new folks coming in so that they can be brought up quicker.
Right.
And that's really where this AI tool will come into play. So the way we see it is that, if we can develop a tool that takes every manual that exists at the plant, all of the history, all of the operating history. If you operate a certain way, you're going to get this much more efficiency. We know that if you see XYZ condition in your pump, that you need to be prepared that something's going to happen. But that all of that knowledge was developed over time. So how do we...
It's almost like an interactive archive.
Correct. Yeah. So how do we catalog that? And that is one product that we're looking to develop. It's collecting all of that information. And that way your junior person can kind of come in and say, well, hey, I'm seeing this. What could this mean?
Right.
And they get an answer.
Right.
Without having to spend all of that time, trying to find the right manual, what's the right, scrolling through it to try to find the answer. It's really targeted towards their equipment, their facility. So that's how we see it, a tool like this and the products that we're looking to develop to augment that exiting staff, to help bring the new folks up to the level of a plant engineer much quicker than they would have otherwise.
Yeah, I imagine as staff is becoming less, not only in part because there's fewer people coming in, but because we're augmenting with robotics and AI, if a problem happens, do we feel like that trust level is there to make critical decisions? Like say, this power plant chat GPT, hey, what do I do next? And it gives you the wrong instruction. Like, what are the safeguards kind of in the way of that?
Yeah. And again, we're still working on the tool, so it's still in development. But what we do try to show is the evidence behind it. So where's the exact reference that, if you're seeing a vibration increase and temperature increase on this particular pump, they're going to get that information that says, hey, you should probably shut down, or some action to take, just to your point. But it's also showing the underlying source. This is how we came. This is how the tool came to that conclusion. And then it can
show you the schematics or the source material. It's going to point you straight to it, and you can double check for yourself before you make a critical decision.
Exactly.
I mean, that seems foolproof to me.
Yeah.
That at the worst case scenario, it tells you something, you look and say, I think it might be off.
Yeah.
But that at very least empowers a single person to be potentially, exponentially more knowledgeable and powerful within their role.
Right. And more efficient. I mean, if you think of if that same person had to figure out where is that manual, where is that section in the manual, is this
is it digitized, or is it in a file cabinet somewhere?
Yeah. Do I have to blow the dust off of it in order to, figure that out? So, so it is meant to be a tool, but in the same vein, there is that human, I mean, this isn't happening automatically. Those actions aren't going to be taken automatically. It's providing, like you said, the information in order to make a better decision more quickly, because you have access to the information and you know where to look.
Right.
But that person still has to make that decision, and they can go and ask their plant manager. They can, and they can say, hey, this is what I'm seeing. This is what the tool is telling me. This is the references that it's giving as justification for this.
Yeah.
Do you concur? So there's always going to need to be that human interaction that really, we'll have to make that decision. But we're trying to be able to get those tools more efficiently, get that information more efficiently, be able to get them to a point where they feel confident in making a decision more efficient.
Yeah. So I'm curious, what is some of like the low hanging fruit at these power plants that is going to be easy enough to offload to robotics or AI?
I would say that, initially going into this, we were like, well, maybe we can have the robot that we're testing with, right, which is Spot, go and do rounds, and, maybe they could augment an auxiliary operator. But to a question I think you had before around, hey, am I going to lose? Is there potential for staff reduction? we don't see it as staff reduction. We see it as if we can have something like robotics go in collecting this data, then we can put the other people to doing things that are maybe more critical, more valuable, more, higher level work. And it's also helping to augment the reality that we just may not have the people that we need going forward, that we may have to, even if we wanted to staff more, we may not be able to, and we have to find other ways, more other creative ways to keep going, to keep operating.
So the transition right now looks like we don't foresee more people being added to the workforce.
Right.
So we're going to have to make who we have more efficient, more powerful, by leveraging AI and robotics and things you mentioned doing the rounds. I imagine, different inspections going around. And in some ways, I could see, that the Boston Dynamics spot, having thermal imaging, these different things. For some of that, I imagine it's more powerful than a person being able to go around. And maybe some of that data becomes a little more consistent. It has a path it travels, or however. How do you look at that?
Yeah, you're exactly right. So the intent is that, when we have Spot has vibration analysis payload. That's it has an acoustic payload. It has photogrammetry payload.
So if something sounds off, if something looks off, if something's too hot in a spot, it's gonna be able to pick up on those things.
Right, things that a human walking around, without that, couldn't do. And the other advantage that we see is that, Spot is going to take these rounds at the exact same point, at the exact same, interval, from the exact same angle every day. So you get that data consistency, which means that the data, data is only as good as it is. It's only as useful as the quality of the data going into the tool. So us making sure that through this way, it's always going to be consistent. That obviously helps. And the other part with having a robot do this is that, it's the consistency, and it's getting those extra data layers that we're not getting today.
Right.
There isn't a person going around and collecting vibration data every day. A plant might do that once a month.
Yeah,
they might have someone
cumbersome to be able to do. Yeah. But for something like this already attached to it, it's not, then really all you have to do is look at the spreadsheet or whatever it produces for you to say, hey, this is an issue. And I imagine as a plant worker, I notice in my own garden, things start growing way bigger, and I look at a picture from a year ago. Yeah. That I could imagine with maintenance in a plant, something slowly decaying over time that it doesn't necessarily hit you that, oh, we should do something with this. Whereas a robot's not going to have those, preconceived thoughts about things.
Correct. Yep. And it's again, you're using a tool that has no bias, right? And that in and of itself will be, will make the data better. And it's also, when we think about what we're doing and what the partnership with Gecko means, they're known for collecting data that's not being collected today. And that's really what we're trying to do, right? If you think of just that example with vibration analysis, you come in and you have, a company come and they do vibration analysis and you get a static report. Well, when something starts to happen 2 months down the line, someone's going to have to go back and be like, oh, was that a factor? Was there something in this report?
And it was only 1 month apart.
Right. Combined with this other, bits of information. Yeah. So we talk about data layers.
The picture becomes clear.
Yes. So then you're putting all of those layers of data into the tool, and it's analyzing all of that where, I've talked to within NAES a lot of our our plant engineers. And when they're trying to make decisions, to give advice to their plant manager about like, hey, I'm seeing this thing, it's a lot of manual work. It's like, okay, well, we have this data point and I'm putting that in a spreadsheet. And then I saw this trend, and so you're trying to, as that plant engineer, analyze all these different factors from different sources and try to present a conclusion. And the reality of the day is that
it's just not possible without robots at this point,
or AI, or a tool, or a platform. Really. Yeah. If they don't have someone who's focused on that, then they're always going to be reactive. They're always going to be, or they're more likely to just having to react to things that are happening, versus anticipating something
Yeah.
and getting ahead of it.
I think about what happened with the Texas grid a few years back, and I wonder, is this type of technology and hardware, would that have been able to prevent something like that?
Yeah, I mean, it's certainly hard to say definitively,
Sure.
but if all of that data was being put into an AI model and they were analyzing conditions that they could potentially have said, like, we're getting to a critical point, you need to do, an action
Right.
needs to be taken and given that advice. Now, again, it still is on the humans to take that action.
Sure.
So, you can never fully define that, but I could certainly foresee where if these types of tools were in place, yes, we could have prevented.
So it sounds like even at the plants that have people where their role is specific to this type of analysis and data collection, the amount of data that you can collect, aside from the robotics and AI, would be so cumbersome to be able to predict some of these things that these AI and robotics, what we're bringing in, the data sets, the analysis, it sounds like a whole new level of predictive maintenance, finding problems before they happen, that just wouldn't have been possible until now.
Right. And it's also about doing better planning, right? If you can, oftentimes certain things are on a schedule and it's maybe not taking in all of those factors, right? So maybe the maintenance should be done earlier. Maybe it can be kicked down, kicked down the road another year.
Help you prioritize.
Right. And then, where we see some of the AI tools coming into play in that area is, well, maybe because of certain market conditions, right? If it's looking at the history of, when prices were the highest, when and there's a lot of factors that go into that. How is that plant bid into the market? What market is it being bid in? There's a lot of factors there. But if that was considered, it may say, you don't actually need to take this outage right now, or you don't need to fix this equipment now. But given that in 3 months, we think the economics are going to be so that you would be at a loss if you had to do it in 2 months when market conditions are in the pricing is different, that you would actually be more beneficial to do it now, even though you don't need to.
Right.
So it's helping to make those strategy kind of asset management, smart decisions.
Right.
And putting that in the hands of the folks at the plant where, they may not necessarily have been considering okay, good, I don't need to do this now, I'll do it in 3 months, but not factoring in that in 3 months, you're going to be, in peak summer conditions and you don't want to do it then. And they, I mean, I don't want to say that plants aren't considering those things. They certainly are, but they may not have the insight to know that at that
There's
time.
a lot of things to juggle, I imagine, running a plant. And
not to mention people, right? I mean, as they still have people to manage. And as we all know, managing people comes with, that takes time and energy as well.
Yeah.
So aside from needing to keep this equipment, this plant, everything running and operational, they also have, people management to deal with.
Right. All of this is very complex.
Yes.
And some of these systems were designed a long time ago, and there's a lot of retrofitting that's going on. And we're inserting AI and robotics into this system. Where do we go from here? Do you think that AI and robotics will make energy cheaper? I mean, what do things look like in 10 years?
Yeah, I mean, that's really exciting to think about. But I think where it's going to have the biggest impact is the fact that, right now, some of the projects or the pilots that we're looking at in testing and with our partnership with Gecko is that we're looking to get some additional efficiency. So, it's almost that low-hanging fruit at the plant. Can we use AI? Can we use these tools to say, wow, we can get a little bit more efficient at the plant? And we're not talking 10, 20%. We're talking 1 to 2%, which may not seem like a lot.
Right.
But what that really means is that you can get more power production at that plant. You can save on fuel costs, but that also translates into environmental savings because, if you can do something more efficiently, then you're not putting out, more pollution into the air.
Right.
It's almost like a two-sided coin because AI is also a tool that's going to help us become more efficient and more productive, but it's also driving the demand right now. So, so we're almost using that AI tool to help us meet the demand of the day.
Right.
But the challenge is that even if we say, okay, we have all this, we have more demand, let's just build more plants. And the reality is that the lead time for a combustion turbine can be 5-10 years. So even if a project is ready to go, they have the funding, they're like, yes, let's build a new plant.
Certain pipelines
right,
that are just
that are bottlenecked. And so it may be 5-10 years before you can actually get that. Well, what do you do in the meantime?
Yeah.
And that's
what
the problem.
What do we do in the meantime?
Exactly. That's what we're trying to solve for is getting out as much efficiency out of the existing generating assets as we can.
Yeah.
And if we can do that, and like I said, 1% to 2%, that's meaningful. That means that we can, over a period of time, that can be the equivalent of adding another plant.
Yeah.
So it's if we can harness that efficiency, even at the small scale, at the low hanging fruit that doesn't require huge investment from these plants, that the result is that we're putting more on the grid and we're helping to meet the demands of right now, which are, data centers, electric vehicles, and all of it. So that's what I see as the most meaningful part to this partnership in this project is that, it's going to help us meet the demands of today while we wait for, the infrastructure to catch up. And we talk about, okay, I mentioned, well, it's going to take us a long time to build those assets, but it's also transmission lines. Those take long, that they can only hold so much capacity. You can only get it to certain areas. And it's like, okay, we'll build more transmission lines.
Yeah.
But that in and of itself takes a lot of time.
Absolutely. Once we get through some of these bottlenecks, transmission lines, making sure that the frequency of the grid is in check, a problem like Spain doesn't happen. What does the future look like for energy?
Yeah, I mean, it's tough to say. I think we'll have more options with battery storage. I think we'd have small modular nuclear, that technology. I think technology is going to continue to advance. Yeah, I mean, for me, it's kind of hard to say what the future of that looks like. I think right now, we're at least NAES and with Gecko, I think we're just trying to meet the challenge of the day.
Yeah.
And we're preparing ourselves and educating, making sure that the people have the right tools and the right access to information, access to knowledge to make those critical decisions.
Yeah. Is there any technology or any problems we're working towards solving that you're really excited about or kind of brings you energy?
Yeah, I mean, honestly, this whole project brings me energy because it's working towards something that is new and exciting. And I think it's also, trying to, as we mentioned, we have older, we have folks exiting, and we're trying to attract people to come in and projects like this, leveraging AI, leveraging robotics, leveraging technology in this way, I think will help re-energize the younger generations to want to be in the space.
Right.
And I think that for me, is very exciting because again, it's not, I interact with some folks that are 10, 15 years younger than me. And I've never heard them say, I'm excited. I want to go into industry. I want to go into power generation. It's all these other things. And, getting people more interested in this field and this work, is pretty exciting.